Chapter 1 Exploration Entering the World of Secondary Science MCQs and Extra Question Answers from Grade 9 Subject Science Book Exploration. Question 1 What is the main focus of science at the secondary stage according to this chapter? Answer C. Deep exploration and understanding how science works. Explanation At the secondary stage, science is not only about facts, it is also about observation, measurement, models, equations, testing ideas, and revising them when needed. Question 2. What does the magnifying glass symbol in the textbook represent? Answer B. Careful observation. Explanation. The magnifying glass symbolizes careful observation, noticing patterns, and paying attention to things that might otherwise be missed. Question 3. What does the compass symbol in the textbook represent? Answer C. Direction in exploration. Explanation. The compass reminds us that scientific exploration needs direction, suitable models, and the right questions. Question 4. Why does science use models? Answer C. To simplify complex systems. Explanation. The natural world is complex, so science uses simplified models that focus only on what is important for a given question. Question 5. In physics, a moving car may be represented as answer C. A single point. Explanation. In physics, a moving car may be treated as a single point when only its motion is being studied. Question 6. When studying a falling object in a simple model, which factor may be ignored first? Answer C. Air resistance. Explanation. To understand the basic effect of gravity, air resistance may be neglected in a simple model. Question 7. In the example of a cricket shot, which detail is important in a simple model? Answer C. Speed and direction of the ball. Explanation. To predict whether the ball crosses the boundary, the speed, direction, and mass of the ball matter most. Question 8. Which of the following may be ignored in a simple model of a cricket shot? Answer D. Color of the ball. Explanation. The color of the ball does not affect whether it crosses the boundary in a simple model. Question 9. Why does science use precise language? Answer B. To communicate clearly and avoid confusion. Explanation. Scientific words have specific meanings so that ideas can be shared clearly and ambiguously. Question 10. Which of the following is a scientific symbol for electric current? Answer D. Capital I. Explanation. The chapter gives examples such as M for mass, V for velocity, F for force, and I for electric current. Question 11. Mathematics in science is mainly a answer C. Language for clear thinking. Explanation. Mathematics helps us express relationships clearly and reason carefully about the world. Question 12. An equation in science is answer B. A compact statement of relationships. Explanation. The chapter explains that an equation shows how quantities are related, not just how to calculate numbers. Question 13. Why are standard units important? Answer C. They avoid errors and ensure fairness. Explanation. Standard units help compare measurements correctly in science and daily life and avoid conversion mistakes. Question 14. The aircraft fuel incident mentioned in the chapter happened because of confusion between answer B. Kilograms and pounds. Explanation. The fuel was miscalculated because pounds per liter were used instead of kilograms per liter. Question 15. A scientific law usually describes answer B. A regular pattern in nature. Explanation. A law describes an observed regularity, often using words or mathematical relationships. Question 16. A scientific theory explains answer B. Why patterns occur. Explanation. A theory provides an explanation based on evidence collected over time. Question 17. In science, a theory means answer C. A carefully tested explanation. Explanation: the chapter clearly states that in science, a theory does not mean a guess. It is based on testing and critical examination. Question 18. Which of the following is an example of a principle? Answer C. Principle of conservation of energy. Explanation: the chapter gives conservation of energy as an example of a principle. Question 19. One of the remarkable strengths of science is its ability to answer C. Make predictions. Explanation: science helps predict what may happen in new situations by using laws, theories, and models. Question 20. Scientific predictions are based on answer D. Evidence and careful reasoning. Explanation: scientific predictions are reasoned expectations based on evidence, not random guesses. Question 21. To make a rain prediction scientific, we should use answer B. Measurable evidence and past patterns. Explanation: the chapter's example of rain prediction shows that humidity, wind, and temperature are useful measurable factors. Question 22. Weather forecasts sometimes go wrong because weather depends on answer C. Many changing factors. Explanation: weather depends on temperature, pressure, humidity, and wind, and tiny changes can grow over time. Question 23. When predictions do not match observations, scientists should answer C. Re-examine assumptions and models. Explanation: when predictions fail, scientists check assumptions, models, and measurements. This improves science. Question 24. Which statement about science is correct? Answer C. Scientific ideas can improve with new evidence. Explanation: no scientific theory is final. Science remains open to correction through evidence. Question 25. The chapter's eclipse example teaches students to answer C. Ask specific questions and look for evidence. Explanation: the chapter uses the eclipse claim to show that evidence, not popular belief, should guide thinking. Question 26. Estimation in science is useful because it helps students answer B. Detect errors and build intuition. Explanation: rough estimates help us judge whether an answer is reasonable or impossible. Question 27. According to the chapter, an approximate answer is often answer C. Enough in early stages of reasoning. Explanation: the chapter says exact values are not always necessary first. Approximate reasoning is often enough to test sense and logic. Question 28. The chapter estimates that a person breathes about how much air in one day? Answer D. 10,000 liters. Explanation: using approximate breaths per minute and volume per breath, the chapter estimates about 10,000 liters of air per day. Question 29. Real world problems usually require answer C. Ideas from several disciplines together. Explanation: problems like climate change, medicines, and sustainable technology need knowledge from multiple branches. Question 30. Science is best described as answer B. A human activity shaped by curiosity and questioning. Explanation: the chapter concludes that science is a human activity built through curiosity, creativity, collaboration, and learning from mistakes. Next, 15 short question answers. Question 1. What is meant by deep exploration in secondary science? Answer: deep exploration means studying science more carefully and thoughtfully. It includes understanding how observations led to measurements, how models are made, how equations describe patterns, and how ideas are tested, revised, or rejected using evidence. Question 2. Why does science use models? Answer: science uses models because the natural world is very complex. A model simplifies a real system by including only the important details needed for a particular question. This makes it easier to understand and study. Question 3. What is a scientific model? Answer: a scientific model is a simplified representation of a real object, system, or process. It helps scientists focus on the most important features and ignore less important details for a specific purpose. Question 4. In the cricket shot example, which factors are most important? Answer. In the cricket shot example, the mass of the ball and the speed and direction in which it is hit are the most important factors. These help predict whether the ball will cross the boundary. Question 5. Why does science use precise language? Answer. Science uses precise language so that ideas can be communicated clearly and without confusion. Many scientific words such as force, work, cell and reaction have special meanings that are more exact than everyday meanings. Question 6. Why is mathematics called the language of science? Answer. Mathematics is called the language of science because it expresses relationships between quantities clearly and accurately. It helps scientists reason carefully and understand patterns in motion, reactions, energy, and many other processes. Question 7. Why are standard units necessary? Answer. Standard units are necessary because they avoid confusion and mistakes, allow fair trade, and make scientific results comparable everywhere. A kilogram should mean the same in every place. Question 8. What is a scientific law? Answer. A scientific law is a statement that describes a regular pattern observed in nature. It is often written in words or mathematical form. Question 9. What is a scientific theory? Answer. A scientific theory is a well-tested explanation of why certain patterns occur in nature. It is based on evidence gathered through careful observation, experiments, and critical examination. Question 10. Why is a scientific theory not just a guess? Answer. A scientific theory is not just a guess because it is based on repeated testing, evidence, and critical examination. It explains natural phenomena in a reliable and systematic way. Question 11. How do predictions help science? Answer. Predictions help science by allowing scientists to test whether their laws, theories, and models are correct. If predictions match observations, confidence grows. If not, scientists improve their explanations. Question 12. Why do weather forecasts sometimes fail? Answer. Weather forecasts sometimes fail because weather depends on many changing factors like temperature, pressure, humidity, and wind. Small differences in these conditions can lead to very different outcomes after some time. Question 13. Why is estimation important in science? Answer. Estimation is important because it helps us judge whether an answer is reasonable. It builds intuition, helps detect errors, and gives confidence in thinking, even when an exact value is not available. Question 14. Why are branches of science not truly separate in real life? Answer. Branches of science are not truly separate because real world problems often involve ideas from physics, chemistry, biology, earth science, and mathematics together. The divisions are made only to organize knowledge. Question 15. How is science a human activity? Answer. Science is a human activity because it grows through curiosity, creativity, questioning, collaboration, testing ideas, sharing results, and learning from mistakes. It is developed by people across cultures and generations. Next, 5 long question answers. Question 1. Explain how science at the secondary stage is different from science in the middle stage. Answer. In the middle stage, science mainly encourages curiosity, close observation, simple questioning, and basic experiments. At the secondary stage, science becomes deeper and more systematic. Students learn not only scientific facts but also how scientific knowledge is developed. They understand how observations led to measurements, how patterns are expressed using symbols and equations, how models are built to represent complex systems, and how ideas are tested, revised, and sometimes discarded. Science at this stage focuses more on reasoning, evidence, and careful exploration. It helps students understand not only nature but also technology and the methods by which science explains the world. Question 2. What are scientific models? Explain their importance with examples from the chapter. Answer. Scientific models are simplified representations of real systems. The natural world is very complex, so scientists cannot always study every detail at once. A model includes only the important details needed for a particular question and ignores less important ones. This makes study easier and clearer. For example, in physics, a moving car may be treated as a single point. In chemistry, atoms and molecules may be shown as spheres and bonds. In biology, cells are shown through simple diagrams. And in earth science, the earth may be represented as a layered sphere. In the cricket shot example, details like speed, direction, and mass are important, while color of the ball or brand of the bat can be ignored. Models are important because they help scientists think clearly and gradually build more accurate understanding. Question 3. Explain the meaning of law, theory, and principle in science. Answer. In science, a law describes a regular pattern observed in nature. It tells us what happens and is often written in words or mathematical form. A theory goes a step further and explains why that pattern happens. It is based on evidence collected through observation, testing, and critical examination over time. A principle is a broad guiding idea used to understand or explain situations. The chapter gives Newton's law of motion as an example of a law, atomic theory as an example of a theory, and conservation of energy as an example of a principle. It is important to note that a scientific theory is not a guess. It is a strong explanation supported by evidence, though it remains open to improvement if new evidence appears. Question 4. How do prediction and evidence make science reliable? Explain with examples. Answer. Prediction is one of the strongest features of science. When laws, theories, and models are well established, they allow scientists to predict what may happen in new situations. These predictions are not guesses but reasoned expectations based on evidence. For example, science can predict how far a football will travel, how breathing changes during running, or how much carbon dioxide will be produced in a reaction. If a prediction matches observation, confidence in the scientific explanation increases. If it does not match, scientists re-examine their assumptions, measurements, or models. This makes science reliable because it accepts correction through evidence. The chapter also shows that weather forecasts are based on specific prediction, though they may sometimes fail because of many changing factors. Question 5. Explain the importance of estimation and interdisciplinary thinking in science. Answer. Estimation is an important scientific skill because it helps us judge whether an answer makes sense. Exact values are not always necessary in the beginning. A rough estimate can help detect mistakes, build intuition, and improve confidence in reasoning. The chapter gives the example of estimating how much air a person breathes in a day and shows that a reasonable approximate answer can still be useful. The chapter also explains that real life problems do not belong to only one branch of science. Climate change, medicines, sustainable technologies, and even understanding how a mask works require ideas from physics, chemistry, biology, earth science, and mathematics together. This shows that science is interdisciplinary. Estimation and interdisciplinary thinking both help students understand the real world in a practical and connected way. So friends, we have completed 40 MCQs, 15 short question answers, and 5 long question answers of chapter 1, Exploration Entering the World of Secondary Science. We have already studied notes and summary of this chapter. You can find the link in the description and on the screen. So friends, we will do MCQs and extra question answers of each chapter apart from NCERT solutions, which will help you in your exams and in future classes. If you like the video, kindly like, hype the video and share it with your friends. Also subscribe to my channel and press the bell icon to receive new video notifications. We will meet in the next video. Thank you for watching.